So, well, Chapter 1, Section 1, Interpreting Graphs. Interpreting graphs, really valuable skill, comes up a lot when you start doing like standardized tests. Being able to get information from here. And you'll find as you go through math that there's different ways to kind of manipulate a graph to make it look like it's saying something totally different than what it is. And you'll cover that in a math class at some point. As far as like definitions go, usually I'm not a big fan of asking you definitions on a test. So I'm not going to say, what's a bar graph, and expect you to regurgitate, our first line here. But instead, if there's a question that says, draw a bar graph to represent this data, you should kind of know what a bar graph is. Fair enough? So that's kind of what I'm looking for. If I want a definition from you this year, I'll warn you well in advance so you don't get surprised on a quiz or a test. Good? So bar graph uses bars to show numerical or numbered data. That's kind of what the book said, so numerical. Or I'm just going to, can I do like the hashtag thing for number? Yep. So numerical are really just numbered data. We're trying to show how many of something there are. So if we were to look at this graph down below, we have guys, we have girls. I didn't even put the numbers over on the side, and honestly, I don't know if this actually fits our class, but do we have more guys? Do we have more girls in class, according to this graph? Girls. So if you have a taller bar, or if it's maybe turned horizontally, if you have a bar that's longer this way, because you'll get some horizontal bar graphs. But if you have a longer bar, it means the number is higher, right? So longer bar equals larger number. I don't even know if that last one's worth writing, but at least we're kind of all on the same page. Fair enough? Should we talk about bar graphs at all? Are you guys, any questions at all? I'm guessing you've seen them, you've used them, you're good, right? And you started doing that even back kind of in kindergarten time. Circle graphs, sometimes they're called pie charts, yes? So circle graphs are pie charts. Basically, a circle is divided into wedges, or what did I have down here? Oh, wedges. Into wedges that show how a set of data compare to the whole. So compare. So often you'll see this done with percentages. Our example here, you can see the percentages of the car sales, between 6 different companies. So you have General Motors is there at 35% at the bottom. Ford is 4%. For these different companies and whatnot. But typically when you go through and have these, they're looking at the whole is going to be 100%. Or you could go through like the people in our classroom and say, what's your favorite animal? And we could try to make like a pie chart, so the whole graph is going to be the total of all of our responses, but maybe there would be like 4 monkeys and 3 tigers and 47 lemurs or something like that. But, we good? Has anybody been to John Ball Zoo and heard the howler monkeys howling? My first time was last week. Holy cow, those things are loud, right?
I did it at Toledo Zoo.
So if you flip ahead, try to throw some things in here and then just kind of come up with some charts. So we could go through and like have everybody answer all of them and then talk it over. We'll probably just kind of go through it together. So in 2010, most people spend their weekend time doing what? So stop. Which one are we looking at, left or right? Go for it. You can say it out loud. Perfect. So we're looking at the right one because it says right here 2010, and this is 2005. So you got to watch for things like that. So most people spend their time, and the answer would be, I'm guessing, the biggest one looks to me like it's that watching films, right?
Yeah. It's close. It looks with family.
Oh, family and friends. Ooh.
It looks. I think watching films looks bigger.
Should we just pick one?
Yeah.
Maybe I'm going to write both, and then I got my bases covered. Fair enough? So maybe I should have picked a different thing. Maybe I should have said 2005. But so family, friends, / films. If I were to give you one like that on a quiz, sometimes I think, oh, it's obvious, and then it's like I look a little closer. It's like, yeah, they're close. I mean, something like that, I might mark you wrong if you picked the with family and friends until the first person points it out to me and like, oh. So if you get something like that on a quiz or test, feel free to say something. I'll try to do a better job with that. By how much did the time spent on hobbies change between 2005 and 2010? So we're looking for hobbies and how much it changed. So hobbies are the brown, right? So you have the brown up here. So if you're looking at Oops. So you're looking at this much of the wedge. 1 sec. Things are going crazy on me. All right, so we have this wide of a wedge, and now we have this wide of a wedge. So you'd say the time did what?
Increased.
By how much? Somebody can just holler it out, that's fine.
Twice.
Yeah, doubled, or so twice as much. So I'm going to say doubled. Now we can't say by 7 more minutes because we don't know how many minutes are on there. We just need to look at the size of the wedge in this case. Where if instead they went through and told you, oh, it's this many minutes over here on the 2005, this many minutes, then you could actually get a number. But we at least can say the wedge is twice as wide. Nice shot. So how much time spent on eating out? Or did the time spent on eating out increase or decrease? Increase, yep. Because we're looking at this thing here. So eating out's this wide to this wide. So I'm going to say increased. So increase. Probably people get busier maybe, or maybe people just have more money in 2010. The economy was doing better. As time has passed, what happened to the time people spent with their friends and family? Decreased. Yep. So as we're initially looking at 2005, it's this almost a third, maybe a little over a third. Now we're at a little less than a quarter of the time. So decreased. All right, those top couple of pie charts, we good on those?
Yep.
Or circle graphs, if you want to call them that. So we were to jump down here. Monday's cafeteria order, slurp this baby off the internet, so it doesn't really fit here. So we have pizza on Fridays, but most students order what? Pizza. Yep. Say pizza there. So pizza. What are the least popular item or items? Go for it.
Grilled cheese and hot dog.
Nice. So grilled cheese and hot dogs. I can see the hot dogs, but grilled cheese?
Yeah.
Come on.
Well,
It's like one of the world's most perfect foods.
It depends who makes it. I've had
That's
a
true.
really nasty
Could be
one
bad
that the
grilled
cheese
cheese.
was like apple
I
sauce.
put bacon.
Yeah, that's true.
I don't.
Ooh, bacon makes everything better. That's why I have bacon Band-Aids at home. Actually do. Okay, how many students ordered lunch? Ooh. How would we figure it out? I hear a calculator, or Carson, what are you thinking? Did it in your head? So what did you do in your head, if you don't mind me?
I just added them all up.
Perfect. So there's 150 there, plus 125 from this one, plus a 50 and another 50 and a 75. And what'd you come up with? 450. Anybody else want to double check them? I'll go with 450. Sure. So 450. And you'll notice here at the bottom I have these learning targets. So you're going to, on quizzes and tests, every question will have a code next to it, such as this like 11A or 11B. So if the question's asking you to get information from a circle graph, it'll have this code 1.1.A by it. And that comes up more on the test that you can go and try to earn back credit for things you missed. For now, I wouldn't worry about those a whole lot, except for maybe just, if you want to, at the end of a section of notes, you can look at it and see, oh, what's Falk going to likely ask me on a quiz or a test, and that's it listed there. Fair enough? Awesome.